Section 3.5 is on proving lines parallel. And this whole section is kind of the converse of Section 3.2, where we talked about if parallel lines are cut by a transversal, then certain angles are congruent. All of these postulates and theorems are going to say that if this relationship exists between these angles, if these angles are congruent, then the lines must be parallel. Let's take a look at the first one here. This is the converse of the corresponding angles postulate. It says if two lines are cut by a transversal, notice it didn't say two parallel lines, just two lines cut by a transversal, so that the corresponding angles are congruent, then the lines are parallel. So if angle 1 is congruent to angle 5, or if angle 2 is congruent to angle 6, or if angle 3 is congruent to angle 7, or if angle 4 is congruent to angle 8, and again all of those are pairs of corresponding angles. If any of those angle pairs are congruent, then line L is parallel to line M. Remember what we had back in section 3.2 was if L and M are parallel, then the angles are congruent. This one is saying if the angles are congruent, then the lines are parallel. And here's the parallel postulate. This didn't come up in the previous section, but it's important as well. Given a line and a point not on the line, so given line L and a point P up here, which is not on line L, there is only one line through that point that is parallel to the given line. So given line L and given point P not on line L, I can only draw one line through P that is parallel to line L. While I can draw an infinite number of lines through P, there is only one line that's going to be parallel to line L. Here's the converse of the alternate exterior angles theorem. If two lines are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. Let's take a look at our picture here. So if I know that alternate exterior angles are congruent, if I know that 1 is congruent to 7 or 2 is congruent to 8, then I know that line L is parallel to line M. Similarly, the alternate interior angles converse. If two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. Let's look at our picture. If angle 3 is congruent to angle 5, or if angle 4 is congruent to angle 6, then lines L and M will be parallel to each other. It's because 3 and 5 and 4 and 6 are pairs of alternate interior angles. And the last one, the consecutive interior angles converse, says that if two lines are cut by a transversal so that consecutive interior angles are supplementary, then the lines are parallel. So looking at our picture, if I know that angles 4 and 5 are supplementary to each other, then I know line L and M are parallel. Or if angles 3 and 6 are supplementary to each other, then I know that line L and M are parallel to each other. And we also have the perpendicular transversal converse. We did have this one in section 3.2. So this says if two lines are perpendicular to the same line, then they are parallel. If line T is perpendicular to line L, and if line T is also perpendicular to line M, then L and M must be parallel to each other. So let's take a look at a couple examples here. Given the following information, determine which lines are parallel and justify your answer. So in this diagram, if I know that angle 1 is congruent to angle 2, then which lines have to be parallel to each other? Well, there's a whole lot of lines going on here, and I really need to ignore a lot of them. But if 1 and 2 are congruent, then it looks like those are corresponding angles. So line R would have to be parallel to line S by the converse of the corresponding angles postulate. Since 1 and 2 are congruent to each other and they are corresponding angles, then line R is going to be parallel to line S. Let's take a look at angles 5 and 7. 5 and 7 look to be, and actually in this case I really need to ignore line T. That's kind of getting in the way there. If 5 and 7 are congruent to each other, they look to be alternate interior angles based around, again, the lines R and S. So R and S would be your parallel lines. Line V would be your transversal. So R is parallel to S by the converse of the alternate interior angles theorem. Now looking at example 3. Measure of angle 3 plus measure of angle 6 equals 180. So if 3 and 6 add up to 180, that is, if angle 3 and angle 6 are supplementary, then lines U and V need to be parallel to each other because these are consecutive interior angles. So line U would have to be parallel to line V by the converse of the consecutive interior angles theorem, which says that if consecutive interior angles are supplementary, then the lines are parallel to each other. And our last example here is angle 3 and angle 7. And this is really rather confusing because I can't quite tell what the transversal would be. Let's see, if I'm looking at R and S possibly being parallel, then no. This larger angle here would have to be one, and this larger angle here would have to be another. If I'm looking at U and V being parallel and T is the transversal, still those angles are not created by just those lines. There's other lines going on here. So I don't think we can tell that anything in particular is parallel. So no lines can be proven parallel. From that given information. Here's an algebraic problem. It says find the value of x so that the line M is parallel to the line N. So if M and N are parallel to each other, it looks like the angles where I have information or algebraic expressions in them, those look to be alternate exterior angles. So this is going to be, I'm going to be using the converse of the alternate exterior angles theorem, which says that if alternate exterior angles are congruent to each other, then the lines are parallel. So 4x minus 23 is equal to 2x plus 17, or 2x is equal to 40, so x is equal to 20. So when the value of x is 20, these two angles, these alternate exterior angles, are congruent to each other, and line M is parallel to line N. And our last example here is a proof. So we are given lines L and M cut by transversal T, and we're not told that L and M are parallel to each other, but actually that's what we have to prove. But we are told that angle 1 and angle 2 are supplementary. Now looking at this diagram, angle 1 and angle 2 do not create any of our special angle pairs. They're not alternate interiors, alternate exteriors, corresponding, or consecutive interiors. They're just two random angles. So let's see where this proof takes us. So my first statement and reason are that angles 1 and 2 are supplementary, and that's my given. Supplementary makes me think that they add up to 180. So the next thing I'm going to say is measure of angle 1 plus the measure of angle 2 is equal to 180, and that's by the definition of supplementary angles. Next thing I can do is look at the picture and notice that angles 2 and 3 are actually vertical angles because they are across from each other when lines intersect each other. So I can say angle 2 and angle 3 are vertical angles. And that's by the definition of vertical angles. And then the next thing I'd like to say is because they are vertical angles, they are congruent to each other. So angle 2 is congruent to angle 3. And that's because you can call it the vertical angles theorem, or sometimes I just like to say vertical angles are congruent. And because back here in step 2 I had the measure of angle 1 and 2 with an equal sign, and here I have a congruent sign, I'm going to go ahead and change this to an equal sign. So the measure of angle 2 is equal to the measure of angle 3, and that's the definition of congruent angles. Now what I have is, looking at statement number 2 and looking at statement number 5, can I do a little substitution here? Both of them have a measure of angle 2. So I think what I'm going to do is take this measure of angle 3 and substitute it into the equation in number 2 for the measure of angle 2. So now I can say the measure of angle 1 plus the measure of angle 3 is equal to 180, and that's by substitution. And if the measure of angle 1 plus the measure of angle 2 equals 180, then that means that angle 1 and angle 3 are supplementary angles. And that's by the definition of supplementary angles. Okay. And let's look back at our picture here. So if angle 1 and angle 3 are supplementary, those are consecutive interior angles, and if consecutive interior angles are supplementary, then the lines are parallel to each other. So I can say line L is parallel to line M by the converse of the consecutive interior angles theorem. You can't say because they are consecutive interior angles. You have to say it's the converse of that theorem, because remember the original theorem said that if the lines are parallel, then the angles are supplementary. In this case, we're saying if the angles are supplementary, then the lines are parallel. And that's how you would complete that proof.